Hi, welcome to my channel. Today we will discuss about naive-Bayes classification algorithm. In this, the contents are what is naive-Bayes, applications, and sample example working process. Coming to the what is naive-Bayes. Here, naive-Bayes is an simple yet powerful probabilistic classification algorithm based on Bayes theorem. Right? Based on the Bayes theorem, we are going to be calculating the naive-Bayes algorithm. It assumes that all the features in the data set are independent to each other. We are going to be assuming that all are the independent, all the features are independent, which simplifies the computation. Right? Despite this unrealistic independence assumption, it performs well in many real-world applications. Under the Bayes theorem, the Bayes theorem is nothing but probability of H by E. H is the hypothesis, E is the evidence. So probability of H by E equal to probability of E by H into P of E by P of E. Probability of where probability of H by E is nothing but posterior probability of hypothesis H given evidence E. Probability of E by probability of H is a prior probability of H. Probability of E by H is a likelihood of E given H. Probability of E is evidence, that is the probability of observing E values. In classification, we are going to calculating the probability of each class of hypothesis given the input feature as evidence and select the class with the highest probability. To classify in that, based on the class target value which having the highest will be taken as a classification and the probability, right? Coming to the applications, we're having the different applications, real-time applications. Spam detection, that is email spam, whether the email is spam or not spam, how we're going to be detect based on the frequency of the words. Here we have the some words which are not related to the mail. All those words will be identified and make that mail as a spam. Next one is sentimental analysis, determining whether a review or a text express a positive or negative sentiments. That the document or a review or the text which will gives the positiveness or the negative. Based on that sentiment, we're going to be classifying whether it is positive or a negative sentiment. Coming to the medical, predicting or the diagnosis, predicting the disease based on the symptoms. So and so having the symptoms, based on the symptoms, the patient having the disease or not. Coming to the financial, that is fraud detection. In that we have the fraud detection. Identify the fraud transactions. That in the e-commerce websites we are going to be transfer the money to purchase the products. At that time we may have the met with the fraud transactions. So that we're going to be identifying those fraud transactions. Text classification. We're going to categorizing the document or a new articles into a predefined categories. Right? We need some political. All the political related documents will come categorized. The same way the articles. Right? Recommended system. That is, we're going to do product recommendation. In the Amazon or Flipkart or eBay, the products are going to be displayed on our web page. How means by frequently we're going to be searching the same item, so that the same frequently searching items will be posted on our web page. Like that, we are going to be applying the naive-Bayes algorithm in various applications. Right? Next, coming to the problem statement. Here we have the car data set with the features such as color, type, region, and stolen. In the color, we have the values red, blue, green. In the type of the car is SUV, Sweden, truck, etc. Coming to the region, here we have the two regions, urban and rural. Coming to the stolen is a target variable. In that we have the binary, it is a binary classifier, yes or no. Based on the past, we need to predict. That means based on the data set, we are going to be predicting that red SUV from an urban region will be likely be stolen or not. Right? What we are going to predict in that red car with the it is a type of SUV and the region is a urban. That car is stolen or not stolen. From the past data set, we are going to be predicting. Right? So we have to take the sample data set. In the sample data set, we have the total 8 examples. There is 8 records, we can say that, with the attributes or features color, type, region, and stolen. Okay. In the color, we have the red, blue, green. Type is SUV, Sweden, and truck. Region, urban and rural. Stolen, yes or no. Clear? Now, step 1. We're going to apply in the Bayes theorem. We know the Bayes theorem probability of H by E equal to probability of E by H into P, probability of H by probability of E. According to the problem statement, I'm going to representing the Bayes theorem like this. Probability of stolen by feature equal to, here stolen is hypothesis, feature is an evidence. Probability of feature by stolen into probability of stolen by probability of feature. For simplicity, probability of feature is constant for both classes yes and no, and can be ignored in comparison. And we are going to comparison, we can ignore also sometimes. Step 2, prior probabilities, that is P of stolen. So for the data set, it is a target variable stolen. From the data set, the total experiments we have the 8. In that, we have the column stolen. It is a target variable. In the target variable stolen, we have the two values, that is S and no. The total S's are there in the data set is 4. In the same way for the no, the total 4. So 4 plus 4 total, we are going to get in the 8 examples. So the probability of stolen equal to S equal to 4 by 8 equal to 0.5. Probability of stolen equal to no equal to 4 by 8. It gives the 0.5. Remember this. This will be utilized in the problem. Lastly, next step 3. We're going to be finding out the frequency table and likelihood table for the color. Right, in our table, we have the features, color, type, region, and stolen. So first one is color. For the frequency table from the data set, I'm going to be generating the frequency table with the column name with the feature color. In that we have the red, blue, and yellow. Total count of S's is 3. No's are 1. For the blue, S are 0. Blues are no. Sorry. No is 2. Yellow, S are 1 and no's are 1. So the total it should be 8. So red total is 4. Blue total is 2. Yellow total is 2. Now we have to calculate the livelihood table for the from the frequency table. That means we will get the total red is 3 plus 1 is equal to 4. So 3 by 4, 1 by 4. But the total is for the blue is 2. Here 0 by 2 is 0. 2 by 2. For the yellow 1 plus 1 equal to 2. So 1 by 2 and 1 by 2. That will becomes the livelihood table for the color. These values will be utilized at the last. Now we are going to similarly we are going to calculating for the types. That is core types. We have the three types from the data set. We are going to be calculating the frequency table for the types. We have the SUV, Sweden, and truck. Stolen, yes or no. So SUV, SSR count is 2, nose count is 2. Sweden S count is 0, Sweden no count is 2. Truck S is 1, truck no is 1. Now we are going to calculate in the livelihood table from the frequency table that we get the SUV count is 4, so that 2 by 4, here also 2 by 4. Sweden count is 2, 0 by 2 is 0, 2 by 2. Truck count is 1 plus 1 equal to 2, so 1 by 2 and 1 by 2. Next we are going to calculating the region. We are having the two regions, urban and rural. In that urban stolen S is count is 2, no count is 3. Rural S is 2, rural no is 1. So total count of urban is 5, rural count is 3. So 5 plus 3 equal to 8. So total 8 records. So we have to get the 8. From the frequency table, we are going to calculate in the livelihood table. In the livelihood table, we will get 2 by 5, 3 by 5, 2 by 3, and 1 by 3. Right? Up to here, it is clear. Yes. Next, we are going to calculate in the posterior probability. In the final, we are going to calculate the posterior probability for the both classes S and No, computing the prior posterior probability. Here, from the beginning, we taken the problem statement that red SUV of the region urban is stolen or not. So we have to consider red SUV and urban. Based on that, we have to get the values, so that I'm going to consider in the livelihood table values here for the color, type, and region. Clear? For stolen equal to S. For that, the posterior probability formula is P of S by future equal to P of red by S into P of SUV by S into probability of urban by S into probability of S. Right? The probability S, the value will be the probability of red by S equals to the 3 by 4. SUV, probability of SUV by S is the 2 by 4. Urban value S is 2 by 5 into P. The total piece in the variable is 4. The total values are total examples are 8. So 4 by 8. So you are going to substitute in the values here. For the probability of red is 3 by 4, SUV by S is 2 by 4. For the urban is 2 by 5. For the probability of S is 4 by 8. By calculating, by simplifying this, we are going to get the 3 by 40, that is 0.075. In the same way, we are going to calculating for the stolen equal to no. For that, probability of no by future equal to probability of red by no, probability of SU by no, urban by no, and probability of no. Right? These values, red no is 1 by 4, SUV is 2 by 4, urban is 3 by 5, and probability of no is 4 by 8. We are going to substitute in the values here, and calculating that we are going to get the value is 3 by 80. After simplifying this, 1 by 4 into 2 by 4 into 3 by 5, 3 by 5 into 4 by 8, we are going to get the 3 by 80, that is 0.0375. Now in the step 5, we are going to comparing the probabilities, that is probability of y by future and probability of no by future. So by seeing observing that, we're having the 0.075 and 0.0375. So since probability of y by s, y by probability of s by future is greater than probability of no by future, So by this statement, we can say that the red SUV is likely to be stolen. So we are going to get the highest value for the S. The naive algorithm predicts that the red SUV for the urban region is likely to be stolen. This conclusion is based on the computed probability of each class given the evidence features. Based on the features, we are going to be calculated the probability, which probability having the highest value. Based on that, we are going to taking the decision. Now you can calculate for this and practice. You can find that for the example one, color blue, type SUV, region urban, whether it is going to be stolen or not. Same procedure, follow the same procedure and find out whether the blue SUV urban is stolen or not based on the data set. I hope that you understand the procedure, how to calculate the and find the probability for the using the naive Bayes algorithm classifier. Thank you.